Okay, so today we are going to be making functions, sinusoidals, from cyclic data. Cyclic means it just cycles over and over and over again. Like you breathe in, you breathe out. Keeps going like that. Breathe in, you breathe out. And you breathe back in again. And hopefully it keeps going. All right, so there's a lot of things that are cyclic like this. Temperatures. Do you get that at certain times of the year we have pretty low temperatures, and then other times of the year we have really high average temperatures? Or it could even be how much daylight we have. It could be tides, the low tide, the high tide. All right, so I want you to look at these two and know that since cosine and sine are basically the same thing, you could write cosine in a way that would shift it over so it would actually be sine. All right, now I know some of you have got this, and other people are like, I don't even know what's going on. Some of the problems today are going to be hard, so you're going to have a partner. We're going to have here, you're going to move up here, and then these two rows, I'd like you to slide next to each other. Go ahead and do that now. These two rows. Let's see. We're going to have you move up here, Jack behind you. And for today, behind you, Jack. And have John come up here and Rhea, can you slide up to your next one? These two rows slide next to each other. All right. You take cosine. That is not sine. But as soon as I shift it, it will be sine. If I just shift it the right way and the right distance, it'll be sine. Talk to your partner about what you guys think. None of the problems today are super easy, so you will want their advice. Okay, let's see who's going to tell me. It's row 2, last person. Nico, that's you. Describe what you think is the right amount of shift to get cosine to be right on top of sine.
Minus pi over 2.
All right, minus pi over 2. Does that look familiar, like it might have been on a sheet somewhere? You know what I mean? Like cosine of that was equal to sine. Oh my gosh, cosine, sine, they're cofunctions. You've maybe seen that before. So it actually makes sense from that perspective too. All right, so we needed to move this over to there. Remember that, because later this hour, that's going to be the key, is to how to get your equation shifted over the right amount. All right, I'd like you to go find a blank space. Could be add a page, could be just slide over. And I'd like you to make a wave like that. Now notice how I didn't start exactly at the very lowest, because life doesn't work out perfectly like that. Like the high tide doesn't happen exactly at 8 a.m. It happens at like 8:04 and 32 seconds. You know what I mean? The real world's messy. So if we could get it to just always start at the low spot, then you just use sine. Because do you get, if I had this moved over just a little bit, then that would be sine. It's just been shifted up. All right. So the reason we always use cosine for writing these equations, everybody above it write A cosine of B parentheses theta minus C plus D. The reason we always use cosine is because of that is really hard to figure out exactly how far that got shifted over. Okay, so otherwise you could use sine and you could shift it over. But this, you'll always know the high spot and how long it took to get to that high spot. And therefore that will be our cosine shift. If cosine had been its high spot right there, then it would have just been normal cosine. But it's been shifted over. All right, so draw that if you haven't already. All right, next, I'm going to tell you that that high spot happened. Now, we're going to use military time. Because if I say it happened at 9 a.m. and then it goes till 1, do you get how 9 a.m. till 1, the math is actually kind of complicated on how many hours that is? 9 till 1 doesn't, I mean, you might count it up and go 9 to 10 to 11 to 12, and then, so it's 4. But you're going to have to count it up, and that's kind of clunky. So we're going to use military time. And this is happening at 900, this is time down here, at 900, 0900 is the way they would say that in the military. That's 9 a.m. 0900 at time, you could call it 9 a.m. if you want, but as soon as I say like 1300, you'll be realizing, oh, wait a minute. Okay, so that's 1 o'clock. All right. At 0900, the depth at this certain beach, the depth of the water, and depth where? Like on a fixed point, like for instance, on a dock pole, okay, was 20. And this will be in feet. We could actually, you know what, let's be meters, because you know what, in the real world, they use meters now, pretty much always. If you're at SpaceX and you're figuring out how tall your rocket is, you don't say it in feet anymore, you say it in meters. Because you want to work with countries around the world. Do you really want to introduce the chance that feet and meters get mixed up? From your plant that's in Germany, from your plant that's in the US? No, you want to use one system. And since most of the world uses meters, as soon as you're a company that's going to go worldwide, you're going to use meters. Okay, so this is feet. No, it's not. It's meters. And this is time, and we're going to use military time. All right. Do you get, I just gave you a point. Please write the point properly. Talk to your partner. What comma what? What's that point? Did you say 900 comma 20? You were right. Okay, now, do you get from that info alone, you could not figure out the equation for all of this. You could actually do some of it, but you couldn't do all of it. You could only do one thing at this point. You couldn't do the amplitude because you don't know how low this low spot is. You couldn't do the amplitude. All right, well, you would have been able to do something. Maybe later on you'll understand the one thing you could have done. But I need to give you this, which is a low spot. And then I did preview this yesterday so that you could theoretically, and several groups did last hour, they could pull this off without me reminding them how to do it. At 1100, it's 11 o'clock, right? That's too quick. No tide goes that fast. I'm sorry. I'm going to change that. 1600. At 1600 hours, it reached the lowest spot, which we will say is 12. 12 meters deep. It's quite a difference. 8 meters. That's a big swing. It must have been up in Alaska or down near Antarctica. All right, so that's all you need. And now you can write me this equation, and I already know, let me think for a second, and I can do this. Okay, I already know the amplitude, and I already know the D, which is how far up it's been shifted. And I know C, which is how far to the right it's been shifted. And B, that's going to take me a little longer, because I'm going to have to use that little formula that I gave you about period. You know, the period is blah, blah, blah. And I said we'd use it multiple times, including on the test. All right, so this is the part where I want you to work with your partner, try to figure out all the parts. Maybe you'll only get 2 of them. If you do nothing else, figure out the dotted line that runs through there. Pausing while you work on that. Okay, there's 4 things to find. I'm curious how many groups have at least confidence in 2 of the 4. Confident about at least 2 of the 4. Any groups that think they have all 4? I said it would be maybe 2 groups, and it looks like it's 2 groups. All right. Now, they might be wrong, but at least they have confidence. All right. That is the number 1 thing that Americans rank the highest in, the youth of America. They may be behind everybody. Not everybody, no, that's harsh. They may be behind the leaders in math by like 16th place, but we are the most confident. All right, so anyways, let's see if you really got it. So first off, that dotted line that ran right down the middle, I would find it by averaging the 12 and the 20 I added them together in my head and I got 32, and then I took a half of that, and that's 16. How many of you had 16 for that dotted line? That's good, because that's how far up it has been shifted. The dotted line would be at 0, but it's now at 16. That means your D was 16. How many had that part right? Okay, cool. If that's 16, then this height right here, that's got to be 4. That's called the what? Amplitude is 4. It goes from 16 to 20, so the amplitude is 4. And then we always use cosine. Why do we always use cosine? Because this shift right here, which is from 0 to 900, and therefore 900, is just the shift you'd put right there. All right, and those are the 3 easy ones. All right, so what's the last hard one? And that goes right here. I'm going to make it blue. It's the B, because this part is always theta and minus, so the only thing left is B. I heard somebody in the back saying a formula that was important at this point. 2 pi over B. So now the problem with that happened both hours, is people told me this as a formula. No, that's not a formula. It needs something else, otherwise it's just an expression. You need both parts of the formula. Period equals that. Yes, you need to know that the period goes there, because then that's the key. We didn't know B, but we know the period. How do we know the period? Because the time it took to get from 900 to 1600 is 700, and that's 7 hours. Is really what that means, okay? So 7 hours. Yes? How do you find C? C came from the shift, and I'm going to write it down for you. It's the x value of the first peak. See this peak here? That peak? That, if it was normal cosine, that would be on the y-axis, like over there. It's been shifted over this far. It's been shifted over how far? That's an x value. It's been shifted over 900. Yes?
And then A, I had 8, but obviously I'm wrong.
Okay, let's talk about y. This blue line was at 16 right here. This black line is at 20. And the amplitude is the distance from this line up to the highest that it ever went. From the center line up, that's the amplitude. So from 16 to 20 is 4. That's why the amplitude was 4. I'm glad you asked. Thank you. All right, so now, how do you get this like neato little formula? Period is 2 pi over b to save the day. Well, it was 700 was the period. No, it wasn't. Yes, because 700 got you from here to here, which is half of a whole cycle. So 1400. It takes 1400 hours, so to speak, or 14 hours, to get you to a complete cycle. Now, if you haven't already, this is the part where you'd solve it. So I'm going to times by b on both sides. And then you'll end up being able to solve and getting 2 pi over 1400. Yes?
Where did you get 1400 again?
All right, so this distance from the peak here, which was 900, I'm going to highlight it, from there to there is 700 hours, so to speak, but it's actually really 7 hours. What? And the reason it was 7 hours is because 9 plus 7 is 16. Okay, and why is it 14 then? Because 7 hours gets you from here down to here, but that's not a complete cycle. The complete cycle has to go all the way back up to the top, so you can assume it would be double that. There we go. Okay, that's a critical breakthrough. I'm glad you asked. All right, so now I have 1400 for that, twice the distance from the low to the high, or the high to the low, either way it would work. And now I am solving. So now my b's cancel, and now I have b times 1400 equals 2 pi. B times 1400 equals 2 pi. So to solve, I divide by 1400, and my b is now 2 pi over 1400. Could I reduce that? Yes, and I don't want to muddy the waters of, Like Mr. Server said, in this unit, we don't have to reduce. No. What I said is, you should reduce, but as you're counting for your pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, it's easier to not reduce until the end. So you should reduce this. So it's pi over 700 is what the reduced number would be. If you want to know how that is best done, personally, I think you go 2 times pi and 2 times 700 and just let the 2's cancel, pi over 700. Okay, so that goes right here, pi over 700, and that is an equation that, and here's the cool part, you could give me any time, and I could tell you exactly how high the water would be. So if I gave you a time, and we put it there, then we'd know exactly how high the water would be. What if I instead was running a military mission, and I needed the water to be at least, well, let me look at my numbers again. I wanted it to be at least 18 feet deep, because otherwise the boat won't float through the channel, because, you know, like how deep the tides, sometimes there are times when you can't get a boat in because it's too shallow, and you need it to be high tide to get your boat in or out. Okay, so then you might say, I need to know, when is it going to be 18 feet deep? And that's like, not the middle, that's like above the midline. So when is it going to be 18? Well, you could put an 18 at the y, or at the beginning, and you could solve. Now, that'd be complicated, but you could. Okay, so that's writing an equation, and I went over it very slowly and carefully there, but now I'm going to give you one more where I give you the numbers a little faster. I'd like you to just draw an xy axis, and you should be able to go, oh yeah, no problem, I can write the cosine equation for this. All right. So this time I'm going to have the low spot start there. And then, of course, it just goes up and down and up and down. Okay. You will always know a high spot and a low spot. And this shift actually can be to this spot, and it would be fine. But I'm going to keep it simple for now and just give you the closest high spot. But just so you know, if we gave you this one over here, it'd be fine to use that as the shift, because it's just shifting it over further. It's like saying, how about if I shift it to over 2 pi? You can do that. Get the same answer. All right, so I'm going to give you this spot, and it's going to be a height of, no wait, I should give you the time first. Time 300 hours, 0300 is how the military would say it. And we're going to go that the water level was at 10 feet deep there. Meters, sorry, 10 meters. And this is time, thank you. It is true. I mean, I bet you if the U.S. could do it for only $1 billion, we would all switch to the metric system. If it just could cost $1 billion, we'd do it. Because there's so many things that get expensive because you make screw-ups between meters and feet. There was that one mission where we tried to send something to Mars, and it screwed up because there was a conversion between meters and feet. And it caused a satellite that was going to go around Mars to crash into Mars. And that cost billions of dollars and so much time from some of our smartest people in the whole world probably, and all because of a conversion thing. So if we just to switch to meters, I would in a heartbeat. Okay, so back to, this is going to be at 0700, and it's going to be, let me think, if that's 10, that to me looks like it's about 4, sounds fine. I was thinking 3, but then you'd have a decimal, and that'd be kind of a pain, so. All right, that's all you need. And now you should be able to write me a cosine equation for this. Work with your partner to find out A, cosine of B, theta minus C plus D. I'll pause for a second, give it a shot, and because I went through that slowly and carefully, you should be able to do this in less than 3 minutes. Pause, and then come back to you in about 3 minutes. So here we go. We're going to start with about 6 different people giving me the first step, second step, third step, and hint. The first step is to find the center line, also known as the baseline, that runs right down the middle of it. And we're going to go with Clara Woods. Tell me how to find that line that runs down the middle.
You just find the number between 10 and 4.
Between 10 and 4. What's that?
7.
All right. If you add them together, you get 14 divided by 2 is 7. You are correct. Okay, next is, how do we use that? Row 1, and this is going to be Eleanor. How do we use that dotted line down the middle? It tells us a couple things.
Yeah, it tells us the A.
All right.
The difference between 7 to the highest point, which is 3.
From 7 to the highest point of 10, which is 3. 3 cosine of, and then what else does it tell me?
It gives us D.
It gives us D because it's been moved up that far. So
D is 7.
D is 7. All right, good. And now the thing we have left is, well, two parts. The B and then the minus C. Make that in green. All right. This is row 2. This one's Nico. Tell me how to find either B or C.
To find B, you have to,
Ooh, chooses the hardest part.
you have to do the period.
Period is
It's 2 pi over B.
excellent. What if we were using tangent right now? Just as a side note, tangent has a period of what again? Pi. It would have been pi over b. But we're using cosine, so you're right. Now what?
And then you take,
Hint, we know the period somehow.
yeah, it's like it's sometimes two.
All right, hint. From here to here is half of a complete cycle. How far was it, Nico, from the two blue lines? 400, as in 4 hours. So then what's the period?
So then the period is that times 2.
So therefore,
So it's 800
8.
equals 2 pi over B.
Yup.
And then you multiply both sides by B, and you get 800 equals 2 pi, and then you divide B by 800, so you get 2 pi over 800, and you can simplify that to pi.
Nice. That is exactly right. Okay, so pi over 400, as we just showed right there. And that goes here. Pi over 400. And then last but least is the C. Dice of Destiny. It wants me to call on Rafferty. Tell me, how do you find out that C number? I'll give you a hint. It's a shift.
Yeah, I'm pretty sure it's 300.
Because?
The top point, 310.
Yep.
Pretty sure that was supposed to be at 0.
Ah, so it's this far away, and you'd need to shift it to the right. That's why there's a minus there. 300. So that should be 300. Notice I'm doing this in military time. So then my answers come out in military time. So if I wanted a time of 4 p.m., I would not put a 4 right there. I'd put in a 400. You know what I mean? No, wait, 4 p.m. That'd be 4 a.m. You know what I'm talking about? That could be really confusing. Because 4 p.m. is not 400. It'd be 1600 for 4 p.m. So this is all done in military time. All right, next. I think you guys get this. I think you guys get how to write the equations for these. How many of you actually had that completely right? Yes, then I can count. You pretty much have this. All right. I'd like you to complete this warm-up page with you and your partner. Try to figure out the answers to all 1, 2, 3, 4, and periods are normally 2 pi, but these have been shifted, so therefore they're not 2 pi anymore. And notice it wants, down in the lower part, it wants the 3 asymptotes of tangent. So, you know, the 2 that you normally use are here and here, but what's this one? And you'll have to think it through. I'm going to pause for a minute while you try to answer those 1, 2, 3, 4, 5 questions. Okay, well, this is easy, 2 pi. This is easy, pi. This one's would have been easy, but then that 2 got in the way. Period equals 2 pi over b, and I know b is 2. So therefore, I can just put a 2 right there. And therefore, period is just pi. Okay, and then this other one, it would have been 2 pi. Oh, wait, no, it's tangent. It would have been period is pi over b. Did you do that one right? And then the period, I don't know, but the b I know. The b is 1/3. and therefore dividing by a fraction is like flip it up here and multiply it by 3 over 1, and now it's 3 pi. How many of you had 3 pi for that one? Ooh, I didn't catch anybody. Nice. This one, this is pi over 2, and I get most people will have these two right, but this, people go 1 pi over 2, 2 pi over 2. It is not 2 pi over 2, and it is not pi either. So what is that asymptote right there? Well, if you figure out what you're really counting by, there's something in between these two. See, just like there's something in between these two, you know, this distance and this distance, that's a total of pi. So you have to add a whole pi to get to the next one. So what's pi over 2 plus a pi? Well, I can make that into 2 pi over 2, and that makes this 3 pi over 2. Another way to do it is this. If you just know there's a mark there, you can go 1 pi over 2. This must be 2 pi over 2, and this must be 3 pi over 2. All right. You guys get that? Did anybody get that right? Oh, only a couple. So, next challenge. We're almost done here, guys. Like, seriously, this might be the last thing. The real world is messy. So, in the real world, they don't just, like, have the answer jumping out at you, like, this point is 2 comma 6, and the numbers aren't so nice. So, my question is, what do you think that is? I know, you're going to have to just read the chart just like I am. What is that point? And how would you write it? And hint, you cannot say July, 8th, comma, 88 degrees, because that would definitely be wrong. You got to find a way to write this so that we can have a distance from here for our shift. All right, I'm going to pause for a second. You and your partner try to come up with your best answer for that. All right. So, do you get that this was a little more than 88, so maybe 90 degrees? This is in Madrid, Spain, by the way, and that's the average high temperature. That's pretty hot in Madrid in July. But if you said July, or July 15th or something like that, you got warm, but you'd have to give it a number. Yes?
7.5.
I like it. It's in months. And she went with 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. Actually, isn't more like 6.5 months. But I get what you mean. But I just counted them. 1, 2, 3, 4, 5, 6.5 months into the year. Oh, what am I doing wrong?
7. January is the first month. February is the second.
Yeah,
March third.
these are kind of weird because they have a mark, as January is a mark. So, do you get how that is a little bit weird? How about this? Let's do it in days, and I'm going to give you a number because I think we can all agree that it's a little more than halfway into the year. Would you agree with that? A little more than halfway into the year. So then, 180 days would be pretty close to halfway. So I'm going to call this 200. And then what should the last day of the school year be? Or not school year. year. 365. Comma, and then that temperature should be about, well, it's a little lower than 53, so let's call it 50. Nice round number. Do you get then? We could write an equation for this. If I told you those were the two lowest, the lowest and the highest, you should be able to do it. It's exactly the same as last time. So give it a shot, you and your partner. I'll pause for a minute. This is your last problem you have to tackle. Yes?
Actually, 195 days.
All right.
After July.
Fine. No, you know what? A lot of people are started with 200. We're going to do it with 200, but I will cop to the fact I just made up that number, and it could definitely be off. All right. So, because people are already started, we're going to stick with 200 and 365. I'm going to pause. Try to write the cosine equation for this scenario. Okay. Right between 50 and 90, I'm adding them together in my head. I'm getting 140, and then I'm going between that, and it's going to be 70. I like to make it a dotted line, but it doesn't really have to be a dotted line for the midline. of 70. If that's 70, then 70 to 90 is a 20, so that's 20 cosine of, and the other thing that tells me that 70 is how far up it's shifted, so that's plus 70. And then, do you remember that the C is the shift? It's this, so it's simple, it's that number. It's the X value, so minus 200 goes there. And this is theta. And then the last thing is the B, and so I just need to know that period is 2 pi over B, and, well, between 200 and 365 is 165. I know this is not perfect, I'm aware. It should be more like half a year, but anyway, it is what it is. It's 165 there. And then I double that, so 200, 320 something, 330, let's call it 330. But do you get this really should have been a whole year? The period should have been 365, but I'm going to call it 300 and, was it 330?
Yeah.
Okay, thank you. Then I'm going to times by b on both sides and solve this thing, and then I get 2 pi over 330, which should really be reduced. But, and I'm aware, it really should be 360. Now, that is almost exactly like the lab that you're going to do. When you come back, we're not going to make you do it over break or anything, but I'm just kind of giving you a preview that the lab is going to be pretty much like that. Do you get how it was real world data? It's kind of icky. You got to like look up exactly numbers in the real world, and then in the end, you can write this cool equation right here that tells you at any time of the year exactly what the high temperature ought to be. And the real world is often different than what your expectation is, but at least you could be like, I'm going to Spain on October whatever, and you could find out, okay, looks like the high temperatures should be around 60 degrees. I guess I'm not going to the beach, you know. Yes.
If we wanted to, could we just take whatever the 365 minus 200 and just put that into the...
I do get what you're saying. In the real world, we're going to ask you to find the actual highest spot, and then you'll get the actual date of that. There's a website called dataandtime.com where you can find out exactly what day of the year October 31st is or whatever. So you'll be looking these up exactly. So no, you can't just assume it's 365.
No, I'm saying for like the 2 pi over b thing, could we not just, instead of taking whatever 365 minus 200 is...
Oh, you just want to jump right to this and not show your work? What do you think my answer is? No, because you need to show your work. But I get it twice now. It comes out to 2 pi over whatever the number is. But we want you to show your work. So, yeah, we want you to start with period is 2 pi over b and stick the numbers in. Okay, just because it's part of showing your work. All right, now this is the part where there are a few more practice problems in here, but I want to end with something kind of fun. So I'm going to just, that's the end of the video for today. And when we come back from spring break, we'll take it from there.